Quick! Knight! Knight!
What is it, King?
There was an evil troll. He took my crown, but he says the only way he'll give it back is if you show him how to calculate these linear and angular velocities of your noble steed bike. Do you accept his challenge?
Of course.
Go.
Well, noble knight, I heard your king wanted his crown.
Did you horse?
Well, you're going to have to answer some math questions first. First things first.
I'm a realist.
No, not that. The real thing first is, how do you measure the diameter of the gear / pedal?
You will first need a tape measure.
Oh.
Take the tape measure and measure the big spoke first.
What did you get as the diameter in inches?
It looks like 8.25 inches.
Oh, he's right.
Now, to get the radius, you divide that by 2.
And for that, you got 4.125, I presume. Well then, how do you measure, next question, how do you measure the rear sprocket, the diameter of it in inches?
You will also need a tape measure.
Okay?
You'll measure it like you did the first.
But the rear sprocket this time. And what number did you get?
I got 5.5 inches.
And how did you get the radius in inches?
Divide by 2.
And what number did you get for that? I presume it was 2.75. Well, last question of this section. How did you measure the rear wheel diameter in inches? It's not funny, noble knight.
You will also need a tape measure, and you'll stretch it out even more,
Oh,
and you will take the measurement of the diameter, which is the widest part, to the widest part.
very complex terms. And then,
Indeed.
I presume you got what measurement?
26.5 inches.
Oh, he is right. How did you then get 13.25 as the radius in inches?
You divide by 2 again.
Oh man, he's right again. He completed my first challenge. My next challenge for the night requires him to fill in these times for these time trials. What he must do is ride his bike from this tree of wisdom as far as he can in 10 pedals. And once he does that, we will calculate the time it takes him to do those 10 revolutions, and then we'll do that 3 times for the same approximate speed. We'll see if he can do it on his noble bike stallion. I'll time it here. Go, noble knight, go! 1 revolution, 2 revolutions, 3 revolutions, 4 revolutions, 5 revolutions, 6 revolutions, 7 revolutions, 8 revolutions, 9 revolutions, 10 revolutions. Well, would you look at that? I got 23.61 seconds for that first one. And by this tree of wisdom right here, I have foreseen that the next 2 times I will get for the trials will be 21.79 seconds and 22.17 seconds, which gives me an average of 22.52 seconds for the amount of average time for 10 pedals. The noble knight has won the second challenge. Congrats, noble knight, but there's one more step to getting your crown. For this last challenge, I'm going to teach the knight how to solve these calculations. Okay. You have to sit through all this learning. So, I'm going to show you how to calculate the angular velocity of the gear/pedals of your bike moving in revolutions per second. Okay, Knight?
Alright.
We take 10 revolutions, which is the amount of revolutions of the pedal that we use, and we had 10 revolutions, and it took him 22.52 seconds on average to complete those 10 revolutions. And therefore, if dividing that 10 by 22.52, we find that his angular velocity, which is the amount of revolutions over seconds, is 0.44 revolutions per second. Understand that, Knight?
Here, here.
So for the second way, I'm going to prove to my knight that I have learned math, is that I'm going to show him what is the angular velocity of the gear/pedals of your bike moving in radians per second. Okay, so we took the angular velocity in revolutions per second, 0.44 revolutions over 1 second, and we're just simply going to convert it to radians over a second by showing the amount of radians over 1 revolution, which 1 revolution is equal to 2 pi radians. And see, the revolutions cancel each other out, and then you simply multiply across, and you get 2.746 radians per second. Understand my math, Knight?
Yes.
Okay, well then I'll show you 3. What is the linear velocity of the chain in either inches, feet, meters per second? Well, I like inches, so I'll show you that, Knight. So, linear velocity equals radius times angular velocity. So, what I simply did is I took the angular velocity here that we had above, 2.764 radians per second, and I multiplied it by the radius, which was 4.125 inches over 1 whole radius. As you can see, we got back here from your measurements. And I got 11.40515 inches over 1 second because the radians cancel each other out. Got that, Knight?
My goodness, you're beautiful.
Well, Knight, this second challenge will involve 2 of these problems, 4 and 5. So, for 4 and 5, it is, for 4, what is the angular velocity of the back sprocket of your bike moving in radians per second? Well, since v equals, which v is linear velocity, equals radius times angular velocity, I simply took the linear velocity, which we found in number 3, and made it equal to the radius, which we calculated on over here for the back sprocket, times angular velocity, which is what we are finding. And when you do that, well, you just simply solve for it as an algebraic problem, and you get that the angular velocity is 4.146 radians per second. And for number 5, we simply do the same thing, but you change the radius to make the radius of the rear wheel instead of the back sprocket. So you're simply using different measurements from this page. Got that, Knight?
Got it.
Oh, he's a smart one. But there's more to come. Well, Knight, for this 6 is going to be more complicated. What is the linear velocity of the bike? Well, we're going to use the rear wheel, which had the number of revolutions that he took, because the rear wheel is what we're calculating for the revolutions. So, the radius of the rear wheel multiplied by the angular velocity, which we found in number 4 for the back sprocket, and then we're simply going to convert that to miles per hour. And then the inches cancel each other out, and the seconds cancel each other out, and the radians cancel each other out, leaving only miles per hour, with miles at the top over hours. And that's how you do number 6.
My
you got
goodness.
that, Knight?
I do.
And for that, we got 3.1212 miles per hour, Knight. You were going slow. Your steed isn't as good as you thought. Oh well. Well, this is the last part of my challenge, Knight. If you do this and listen to it and understand it, then you'll get your king's crown back. Okay, so for 7, we have to find how far we traveled. Well, as everyone knows, distance equals rate times time. So, all we did was we took the rate which is 3.1212. And we simply put that over hours, so that many miles over 1 hour. And we simply converted it so that the amount of time, hours, was canceled out, leaving only miles. And then also did a conversion to change miles into feet, which is what number 7 was asking for. So, 5,280 feet in 1 mile, that cancels miles out, leaving only feet. And 3,600 seconds in 1 hour, that cancels hours out, leaving only feet per second. Well then, we canceled seconds out by taking the average time, 22.52 seconds over 1, since that is the time in r times time. And by canceling seconds out, then all we're left with is feet, which is 103.09 feet. And that was our answer for number 7. Do you get that, Knight?
Do I get the crown?
I solved your math problems. Where is my crown?
Okay, you defeated me. I gave your crown to the troll on the bridge. Go get it, you math expert.
Troll, where are you?
Why, I'm here. Who disturbs my bridge? Oh, you're the math expert that got all those calculations.
I want the crown.
Well, for completing your math, you will have the king's crown. Goodbye, Knight. Knight, did you defeat the troll and get my crown back?
I did.
My crown! I now, by giving my crown back, name you a mathematician. Knight, is that you? Did you defeat the troll monster?
Thank you.
Knight, is that you? Did you defeat the monster and get my crown back?
No. I'll read it.
What number did you get?
8.25 inches.
Oh!